Really happy to see you all here with us today. We've got a fantastic session coming up. My name is Idit, and I'm the head of community and open source marketing at Iguazio, acquired by McKinsey. And today we're going to be talking about improving LLM accuracy and performance. As we speak with a lot of clients and folks in our MLOps Live Slack community, we hear many people ask repeated questions of how do we improve the accuracy and performance of our LLMs? How do we overcome risks? How do we reduce costs? Is that possible? These appear to be challenges that many people and organizations feel today, and that's just the beginning of the types of questions that we're receiving. So we're here to discuss all those questions and more with you today. Today, we're looking forward to having Margaret and Vijay from Databricks on our MLOps Live series. Margaret is the Director of Strategic Alliances at Databricks, and Vijay is a Senior Partner Solutions Architect at Databricks. They'll be talking about DBRX, the common challenges in GenAI solutions, different ways to improve model accuracy, along with practical examples and tips related to LLM evaluation and fine-tuning models. We're really happy to have them here with us today. We also have our very own Yaron Haviv here with us. Yaron is the co-founder and CTO of Iguazio, which was acquired by McKinsey last year. He's going to be talking about GenAI and diving into GenAI references and architecture and application examples and a lot more. Now, a few housekeeping items before we get started. We get this question all the time. This webinar will be recorded and sent to you after the webinar. There's no need to worry if you missed something, we've got you covered. As always, we'll be taking the questions live. I know that's a really interesting part of the webinar. So in order to make sure that we don't miss your questions, please send your questions in the Q&A tab on the bottom of the screen. A lot of you like to send them in the chat, but I urge you to send them to that tab so that we'll make sure to do our very best to get through all of them. We'll also be running 2 polls during the session, so please do fill those in. They help us make these sessions as valuable as possible for you, and we'll make sure to share the results with all of you live. We'd like to invite you to join our MLOps Live Slack community where we will be continuing the conversation afterwards and answering any additional questions that you may have. We'll go ahead and share the link now in the chat. And we're going to go ahead and put everyone on mute, and we'll be recording the session so that we can send it to you right after. And without further ado, we'll get this party started. I'm very happy to invite Margaret to begin. So without further ado, I'll give you the sharing rights. 1 second.
All right, and I think Vijay will be sharing our slides. Wonderful. Thank you so much for the intro, Idit. It's wonderful to be with you guys, and thanks to our audience for joining. So as Idit mentioned, my name is Margaret Amori. I lead our GenAI partnerships for Databricks. I actually came over to Databricks through the Mosaic ML acquisition, and I'll talk a little bit about like what exactly that means for our Databricks users and partners today. We've got about 20 minutes or so. I'm going to first briefly touch on some very high-level positioning. What is the GenAI approach on the Databricks platform today? And then I'll hand over to my colleague, Vijay. He'll walk through some specific techniques, approaches, tools for improving LLM performance and accuracy, not just of models, but of entire AI systems as well. So to start with, what you're seeing on the screen here, really with the acquisition of Mosaic ML this past summer, we combined a world-leading powerhouse in data management and analytics with a top platform for training generative AI models. Ultimately, what we call this combination is the data intelligence platform. Next slide, Vijay. This really opens up a whole new world of possibilities for folks to democratize data and AI across an organization, to feel confident about deploying these AI solutions at scale in production. And where exactly does Mosaic fit within the Databricks platform today? If you click forward, Vijay. Essentially, for those who are familiar with Databricks or the now called Data Intelligence Platform, it's a very modular approach to building different analytics and AI solutions. You'll see on the upper left, this is where Mosaic ML, now branded as Mosaic AI, will sit within the Databricks platform. Mosaic really showed up with 4 key capabilities. It was the ability to customize and fine-tune LLMs, to pre-train from scratch, not just LLMs, but diffusion models as well. The ability to then deploy these custom endpoints, so model serving, essentially. And then the 4th capability was to basically pay per token or engage with and use vanilla foundation models. So those 4 key capabilities are in different stages of full integration into the Databricks platform. Back when the acquisition closed in July, we were quickly off to the races and got 3 out of the 4 fully integrated. And so these capabilities can now be accessed natively through the Databricks platform. And as you can see underneath all of these different kind of building blocks is the open data lake and the ability to kind of engage with data at different levels within your pipeline, giving qualities of data governance, assurance, access controls, which then flow through to AI systems that you're building. Next slide, Vijay. So as the title of the webinar alludes to, we're really going to double click on the increasing accuracy and increasing performance of models and systems. Of course, there's benefits within the platform for reducing costs. This is something that we've been really focused on since day one. Reducing risk is a huge factor in making sure that folks are confident in deploying these solutions at scale in production. So some of these benefits you'll kind of... Oh, sure. Okay, sorry. Yeah. So as the title of the webinar alludes to, we're really going to focus on improving the accuracy and the performance, not just of the LLM models, but of AI systems as a whole. Of course, there's benefits for reducing cost and reducing risk within the Databricks platform. You know, cost and driving down costs has been something that we've been focused on since day one. And then, of course, we need to make sure that enterprises are comfortable deploying these generative AI systems at scale in production, and reducing risk is a huge factor in making folks comfortable. But really, the focus today is on the upper 2 boxes, the accuracy and the performance of not just models, but systems as well. Next slide, Vijay. So lots of different ways, and it kind of goes from, you know, very easy to get started with, down to a little bit more complex and involved. And we'll touch briefly on each one of these 4 different mechanisms. So from prompt engineering, which is a way of simply just crafting prompts, system level prompts and input prompts in order to guide model outputs. Vijay will talk a little bit about some methods that we see folks benefiting from on the Databricks platform. Also with retrieval augmented generation, so the ability to pair an LLM with a vector database in order to customize the output of the model. Maybe a little bit more involved than prompt engineering, but certainly improves the level of accuracy and performance of a system. We'll talk a little bit about fine-tuning. So specifically, what does this mean? And, you know, I tend to argue fine-tuning sometimes isn't very fine at all. It could be a massive kind of overhaul of the entire weights of a model, right? So it could definitely be much more involved. And Vijay will talk a little bit about the different methods of fine-tuning available within the Databricks platform today. Everything from smaller scale instruction-based fine-tuning to what is now known as continued pre-training, where you're really teaching a lot of new information into the model itself. And then finally, pre-training. We're not going to belabor pre-training, but we do want people to know that it is a viable option. It is something that we can do out of the box in more or less a turnkey fashion within the Databricks and Mosaic platform. And Vijay will point out specifically some of the benefits to pre-training a model, AKA building from scratch, right? Like you have a very specific use case, very narrowly defined, and maybe latencies are a key consideration to your system. And so you're really going to benefit from having a smaller, more focused LLM. And so Vijay will talk about one use case that we see a lot of benefits from when it comes to pre-training. So again, light lift, easy to get started with prompt engineering, all the way kind of ticking through to pre-training. And as you would expect, it goes from easy to, more involved. But benefits are in terms of, improving accuracy and improving the performance of the models as you kind of go down that journey. Next slide.
Yep.
And Vijay, I will hand over to you.
Yeah, thank you, Margaret. So just going back to what Margaret just covered, right, at a high level, there are these 4 techniques. And as you go through each of these techniques, you get increasing levels of control. And if you get it right, you can get greater accuracy at a lower cost. So in the next few minutes, I'll be taking you through each one of them one by one, very briefly, just to see what you can do at each level in order to improve accuracy and performance. So we'll start off with prompt engineering, which is like the simplest place to start, but it is an important place to get right. And there are several techniques you can use at the prompt engineering layer to get better performance in terms of higher accuracy as well as lower risk. So for example, you can simply ask the model not to make things up. And that has an impact on hallucination, believe it or not. You can also do things like asking the model not to probe for sensitive information, which can protect you from some very basic risks. And when it comes to crafting your prompts, generally you want to create robust prompt templates that have proper system instructions that allow the application to respond in a smart way. So one method is to ask the LLM to reason step by step. This is a technique called chain of thought for reasoning, and this yields significantly higher accuracy and can be helpful in a lot of scenarios. So that's just a few basic things at the prompt engineering level. Moving on to RAG. So RAG is where there is a little bit more upfront preparation, but this helps you make your application be much more grounded in domain-specific knowledge. So with Databricks, we actually make creating RAG architectures extremely simple. You simply point your application to a Delta table that's in your Unity catalog, and you pair it up with an embedding model. And using that, using a simple UI action or API call, you can create a vector search index. And the beauty of this is that Databricks automatically manages all the ingestion pipelines behind the scenes in order to keep this vector index up to date. So all that underlying infrastructure and management is handled for you. You can simply get a simple API endpoint where you can do a similarity search, where you can pass in a query and get back relevant documents. Again, this is really helpful in terms of grounding your LLM's responses in actual documents that can be a source of truth. So that's from a RAG perspective. And you can honestly get quite far with just prompt engineering and RAG alone. But today we want to talk about why you might want to go beyond RAG into fine-tuning and pre-training. So let's start with fine-tuning and see why we might want to train your own LLM. The biggest reason tends to be improving an accuracy on task. So for the given task that you're trying to optimize for, if you want the language model to behave more appropriately, that's one big reason to fine-tune. Another common reason is to actually, with fine-tuning, you can end up with a much smaller and narrowly focused LLM that can perform better from a cost standpoint as well as from a speed standpoint. With a fine-tuned model, you can often eliminate some third-party dependencies, such as making external API calls or having additional components in your application, which can lead to a simpler application. It can also be more secure because you're not making those external API calls anymore. And you can also embed the knowledge, your domain knowledge, and create your own IP. So that the fine-tuned model that you end up with, the beauty of it is you own the intellectual property that is associated with that, and you can use that to drive your unique competitive advantage. And Databricks platform actually supports a couple of different types of fine-tuning. So the first one we'll talk about is supervised fine-tuning. So this is all about enhancing how the model behaves. And here what we are doing is we are giving the LLM a few examples in the form of prompt response pairs. And we are essentially adapting the model to a new task. And based on that, it can change the response style that is better suited for your application. You can also do continued pre-training. Continued pre-training is slightly different in that here you're enhancing what the model knows. So you can do continued pre-training by just giving the model some raw text to learn from. And through this process, it can learn new vocabulary that is specific to your domain. So it can actually get smarter about the domain that you're doing continued pre-training on. And so the first question, the first step in any fine-tuning job tends to be to select the right base model to start from. And this is where our AI, Mosaic AI Playground can be really helpful. Because Mosaic AI Playground gives you like an interactive way to play around with different base models of different sizes and different context windows, and experiment with the ones that are best suited to build upon. Now, you might sometimes choose a smaller model, such as a 7 billion parameter model, if you want better performance. But if you want the model to have greater world knowledge, if you want to ground it in more world knowledge, you might choose a larger 70 billion, 30 billion or 70 billion parameter or larger model to have that better world knowledge. Now, when it comes to fine-tuning, Databricks actually exposes a very simple API. So it's literally a simple function call where you're passing in, you're specifying which base model to start from. So in this case, we're using DBRX, but it could be any of these the different models each with a different context length. You simply point it to your training data that is sitting on Unity Catalog. And then you can also specify where to store the fine-tuned model, which results from this process. And some basic parameters like how many batches or how many epochs you want to train from, and the type of training task. So with just a few parameters, you can get a fine-tuning job going. And the beauty of this is that the system kind of hides all the hardware complexity from you. You do have the ability to customize this if you really choose to, but a lot of times there are sensible defaults that will get you quite far, that just work right out of the box. Now, we have with the new fine-tuning product that is coming, so we looked at the fine-tuning API, but there is also a fine-tuning product which is currently in private preview, and this actually makes it even simpler. So this what this does is it gives you an AutoML like experience for the end user, where it's dead simple. You just point to your data in Unity Catalog, and then all the infrastructure provisioning is handled for you. The resulting model is automatically registered in Unity Catalog, and it is ready you can seamlessly then deploy it to model serving. And then you can enjoy things like token-based pricing, all in a very simple architecture. So this is something that's exciting that is on the horizon. It's in private preview, so if you're interested, you can sign up for this. Now, when it comes to model training, both for fine-tuning as well as pre-training scenarios, what we found is that faster training often equates to lower cost. And we have seen dramatic improvements over the years in these costs coming down. And a lot of these come from the optimizations that we have been building into the platform. which are able to achieve greater parallelism and more efficient training techniques. So one of the things we've seen is that when we trained Stable Diffusion back in September 2022, the cost was around $600,000, and that dramatically came down in a matter of couple of years. We've seen that it came down like 4x each year, and now we are able to train the same model for less than 50K. So there's dramatic improvements that we are seeing as a result of all the optimizations we're doing to both the software stack, as well as improving the hardware accelerators and new methods. And you know what applies to Stable Diffusion type models also applies to LLMs as well. We do have another great method to improve accuracy is to train using better data. And this is an area where really the Databricks platform really shines, because you can use the power of the Databricks platform to create fully managed data pipeline that does all the data preparation and improves data quality, which ultimately is used to train what we call as a dense model. So training a dense model is actually significantly more efficient. The combination of a dense model and high quality data can yields, and we have seen this in action, it yields great improvements. So just as a quick example, we trained using similar size of data sets, like 1 trillion tokens. We recently trained DBRX on this. A year ago, we did the same thing for MPT. And what we've noticed is that for the same amount of compute that's measured in flops, our gauntlet score actually went up dramatically. So this is like the evaluation benchmark score that we use to evaluate. So using the same amount of data, same amount of compute, you can get a much better performance. So that is something that is really something to make use of. Now, we talked about the model training part, but there are efficiencies to be had on the serving side as well. And this is where serverless model serving really delivers better, lower latency. Like we have seen big improvements through optimized model serving, which can bring down latency by up to 5x. And latency is the time to first token. The throughput is also improved in this through model serving. And throughput is the amount of tokens that it generates per second. So we have seen dramatic improvements in both of those metrics. And the serverless model serving also makes it extremely simple with minimal configuration. So you simply pick a t-shirt size for the type of model serving infrastructure you want, and all the auto scaling is handled for you. There is also on the roadmap, we have a scale to 0 option that is super exciting, that is coming soon. And so going beyond fine tuning, this is an area where we can push the boundary even further with pre-training. And so this is an example of a biomedical language model that we built in collaboration with Stanford. Margaret, if you don't mind, I know you're closer to this one, so if you could say a few words about this slide.
Yeah, absolutely. So this is just an example of pre-training. And I always love to point this out because a lot of people immediately think, oh, no, I'm never going to need to pre-train. And so what we want to tell people is that it's actually more approachable than they may realize. And it's maybe not as expensive as they might think. So for example, this is work that the Mosaic team did with Stanford's CRFM a couple of years ago. CRFM is Center for Research on Foundation Models. And essentially we set out to completely build from scratch a biomedical model. And it's a 3 billion parameter model, so quite small. And it was completely trained on biomedical information. For this one, it was the National Library of Medicine here in the US, They have a database of medical literature, research papers, things like this. And so what we put into this model was 16 million abstracts and 5 million full text articles. We trained it on the Mosaic platform. The cost to train was about $30,000, actually it was less than $40,000, so $38,000 specifically. And what is worth pointing out on this pre-trained model is the fact that when you compare the accuracies of this model to a similarly sized model that was fine-tuned, also on medical literature, it really outperforms the fine-tuned version of the other model. The GPT-Neo model is the one that we compared it to. This is a model, a really popular model that was put out by Eleuther AI several years ago. And so I guess, if latencies are important for you, then, go smaller. If accuracies are important to you, then really consider pre-training, because you can really purpose build a specific model for your exact use case.
All right. Thanks, Margaret, for that. Yeah, so the next topic I wanted to quickly touch upon is evaluation. So we looked at approaches for fine-tuning models, but how do you know if you're on the right track? That's where evaluation really comes into the picture. Now, evaluation is actually quite a challenging topic. And one of the things about LLM evaluation in particular is that many of the approaches that used to work in the classical ML and deep learning settings, they simply don't work as well with LLMs. It's often hard to establish quality benchmarks, especially for new domains. And there is a lot of reliance on human judgment, which is both very costly and error prone. So this is where having the platform help you with some tooling for evaluation actually makes it a lot easier. So with the Databricks platform, there are a few things that it provides to help with the LLM evaluation. So the first piece is the AI playground, which is more for the manual interactive evaluation, which I'll touch upon. And then there is also MLflow Evaluate, both for evaluating retrievers in a RAG setting, as well as for the LLM itself, where you can actually set up custom metrics for benchmarking. And you can, implement things like MMLU, by giving it like question answer pairs. So all that can be built into your evaluation workflow. So with MLflow evaluation, the nice thing is you can use the LLM as a judge paradigm, and you can actually have it log metrics around things like toxicity and bias. And you can also measure model latency if you're interested in improving performance. So all these things can be logged and tracked over time. So you can make sure that it's headed in the right direction. You can also do what is called as a fine-tuning vibe check. So as you're fine-tuning an application or a language model, you can periodically look at for a given input, what the output looks like at various stages in the process. So you can look at it at step 100, step 500, step 1000 to see what output you're getting and visually confirm whether it's on track or not. So that's a nice thing from a manual perspective. You can also do this more systematically and look at model metrics like perplexity and cross entropy. And you can log those and graph those over time and use that for deciding when to stop training your model, for example. And then, so we looked at those model metrics. There are also system level metrics that you can get insight into. The most important ones tend to be GPU and memory. So you can, build these, you can actually get a lot of these observability out of the box. And you can also define custom metrics to watch these over time. And all this really comes together in the form of lakehouse monitoring. Lakehouse monitoring gives you an end-to-end way to analyze all aspects of your AI pipeline That includes using inference tables, which can analyze inputs and outputs that are coming out of your language models. You can also build out visualizations like the one you see here, and you can set up automated alerts. So for example, if your data quality is going sideways, you can actually set it up so that you'll get alerted. And you also get the benefit of lineage tracking and end-to-end lineage tracking that is provided by Unity Catalog. And last but not least, a very important topic is that of responsible AI and guardrails. So the entire Databricks platform has been built with responsible AI in mind. And there are safeguards that are built in at every stage of the AI lifecycle. So that goes all the way from raw data and data preparation, all the way to model governance as well as data governance, and having safeguards to reduce risk at every step of the way, all the way to model serving when it is in the form of an end user facing application. So everything is built into the platform, and you get the benefit of all this. All this is described in a white paper that we have linked to here. Definitely it's a great place to start from a secure, responsible AI standpoint. So hopefully what I've covered today, what both Margaret and I have covered today has sparked your interest. I definitely encourage you to get hands-on. That's the best way to learn. We have actually provided a chat bot you can access by using the QR code on the right. I'll quickly show you what that looks like. So you can ask some simple question answers. This is a DBRX bot. And you can get to know DBRX and how it behaves, and also tweak how it responds in various scenarios. I also encourage you to try out the Mosaic AI Playground, which you can see here. There are some chatbot demos that we make available in the form of notebooks that you can try out in your Databricks workspace. I also encourage you to participate in the fine-tuning preview and get to explore that further. And also one last shout out is please join us at the Data and AI Summit. It's coming up in June in San Francisco, and the registration link will be provided. So with that, I'm going to stop sharing and turn it back to Iguazio.
Thank you, Vijay. That was fantastic. And Margaret has been taking the initiative and answering a lot of your Q&As. There's so many great questions that are coming in. So you can take a look at some of her answers. Let's leave some of them for the end as well, so we can have an engaging live Q&A. And without further ado, I'm going to go ahead and launch the first poll. I'm going to go ahead right now, and we want to hear from you. So where are you on your GenAI journey? Okay, so yeah, where are you on your GenAI journey? Are you just learning about GenAI? Do you have a specific use case in mind, or have you already begun building a GenAI app? Some of you may also have a GenAI app in production. So if you don't mind taking a second and just filling that out and letting us know where you are in your GenAI journey, that would be really helpful. We'll give it a minute or two because there are a lot of you here that joined us. The answers keep coming in. All right, we'll give it one more second and then we'll continue on with the webinar. We've got lots to discuss. All right, fantastic. Thank you everybody who shared where they are in their journey with us. And don't worry, we'll share the results with you at the very end of the webinar, so you can see what everyone chose. All right, so let's go ahead now. I'm going to introduce Yaron to go through his slides.
So first, thanks for the Databricks team, and this was very interesting and a lot of details. We've been working together on various projects and implementation, and also, we will have a presentation around GenAI with deeper demos at the Data and AI Summit soon. Anyway, we've been talking about the overall application framework of how to build GenAI, and some of what we've seen are individual services and capabilities. And we need to put all of those in the context of the overall GenAI architecture. And this comprises of those four elements that we keep on talking about, which are, the first one is the data management, how to take data, raw data, unstructured data, and work on that, build various transformations to improve the data, improve the quality, and then either index that in a vector database or in some other form, or use it for the fine-tuning. The next step is to essentially build a model, fine-tune a model, or even use an existing model, but test it within the context of the application, drive a lot of different permutations of tests, evaluate the results. We've seen some technologies of how to evaluate LLM performance, and this could be deployed as part of the, let's call it CI/CD, or the development and test framework for the model and the application. And finally, once you have your fine-tuned model or ready-made prompts and other application pieces, you deploy them into production. The next place is how you build overall application. So LLM is just one portion of the entire application. The application consists of, handling the request, front end, contextualizing the request with additional data, whether it's from vector databases or other database, prompt engineering, LLM, and so on. Usually this gets deployed as microservices where there is a call to the LLM. And the final piece is that the monitoring is essentially taking all the telemetry data from all those different pieces, monitoring, being able to figure out if there are hallucinations, is there bias, do we have a drift in the model, and so on. Some of that data can actually be used, and we've shown that in the previous webinar for RLHF. We're actually further improving the model, and as we've seen in the recent webinar, we can improve the accuracy of the model quite a bit by adding this feedback loop. So this is the overall framework that we're seeing. And based on that framework, this is how we're designing a solution. Let's move to the next slide, Edith. So this is an example of how you take all of those things we discussed today and build an application, GenAI application. So we have the data pipeline. This is where we ingest data, unstructured data, and we save it, store it into various types of storage, structured, unstructured, tabular, real-time or not. This is where we can use Databricks and Spark and the traditional data engineering tools to do that. Although some of the data engineering are more unstructured oriented, so they'll include NLP transformations and so on. We've been doing a lot of work with Databricks and MLRun to essentially be able to build those workflows and deploy them very easily using some MLRun capabilities that orchestrate the Databricks engines underneath. You can use Delta Lake and other facilities from Databricks to store and index and the metadata and the data. In the ML pipeline, you can use the Mosaic technology in Databricks to essentially fine-tune the model, along with MLflow as a way to track the progress of those model training jobs and manage the artifacts of that and so on. And MLRun could also be used for orchestrating and integrating that CI/CD process. And these are also integration we've done together with Databricks. And the application pipeline you see here has those orange boxes. These are the LLMs. This is where we're calling a model. We may actually have multiple models. Many applications, we have different models that are focused on different stages of the application. This is the best way to achieve the best performance and lowest cost by, instead of using one huge model to do everything, you'll use different models that are more suitable to one or the other application. In some cases, you have models that are more oriented towards classification, or maybe models that are visual. Some model handles audio, some models handle text. You may have applications where on one end you classify a user based on his features, which is traditional ML, and you use that classification in order to drive an LLM request or a prompt. So you can even have hybrid GenAI plus ML models. But what you can see here is that you need to build a sort of application pipeline, and the application pipeline will call into the LLM. And you can call into different types of LLM. It could be a service of LLM like OpenAI or Cohere and so on. It could be going to the Databricks serving endpoints, as you've seen in the presentation, or it could be deployed using some of our technology called Nucleo, which is an open source high performance serving engine for those purposes. And again, you need to build this full application flow. Finally, you take all the telemetry from all those different things, and those can be pushed into a monitoring system. We've been working a lot on adding to MLRun all the aspects of LLM monitoring, again, hallucinations and other pluggable options that will allow us to orchestrate the monitoring across various third-party model and LLM monitoring tools, and use things like Grafana as dashboarding, and take the output as a way to further do the fine tuning and export them, for example, to the Mosaic platform, so you can push it into the fine tuning. There's also technology by Databricks. I think it's called Lakehouse Monitoring, which also allows you to take all the data and store it in the Databricks data lake and leverage it for performance and matrix and telemetry. So that's in general the overall way that we see building the application. We as McKinsey and Iguazio were essentially partnering with Databricks to build all of those different capabilities, as well as some ready-made application recipes. So clients that come to us, we can accelerate their journey and also make sure that they get the best production worthiness and enterprise grade for their solution. So with that, thank everyone that joined the webinar and our presenters from Databricks. And let's see if we have any additional questions.
Thank you so much, Yaron. That was really helpful to have that deep dive. Without further ado, I'm going to go and launch the second poll here. We've spoken a lot about different LLMs. We want to hear from you again. We want to hear from you. Which LLM do you have the most experience with? So there are a bunch of popular tools out there. Please let us know which you use the most. See a lot of different responses now. All right, we'll give it a couple more seconds. GPT seems to be getting the most votes right now, but don't worry, I'll share the results with everyone at the end. Okay. So before I do share the results with you, there are a lot of fantastic questions. I'm going to stop sharing my screen, and Margaret and Vijay, if you want to go on and put on your videos. Margaret, you're fantastic. Vijay, you're incredible. You guys answered so many of the questions throughout the webinar, but I do believe that maybe other people want to add on to the questions that you've answered. So I see there's a few open ones. All right, so wow, there's so many here. Okay.
Yeah, there were some great questions, and there were a couple that we touched on earlier that are really good questions, and maybe we could have an entire discussion around them, so we can always bring those back up. There was a good one around how to look at RAG versus fine tuning, when to do one versus the other. Maybe you want to do both, so we could talk about that. Or the toxicity question and LLM as judge. I think two people asked about LLM as judge.
Yeah, there were definitely repeated questions. So why don't you go ahead and start about fine tuning versus RAG, and then, you know, Vijay and Yaron as well, open it up to everyone so we can hear your opinions on that.
Sure. I mean, I can start with the fine tuning versus RAG. Our general rule of thumb, and I alluded to this in the answer, is for data that is fluctuating constantly, it's, you know, supply chain data, it's weather information, things like this. No one's going to keep a super frequent cadence on fine tuning, you know, every week, for example. So really that type of dynamic data set is best in a RAG type of pairing with an LLM. One thing that we have seen is where the data doesn't fluctuate that much, it's fairly static, that information could be baked directly into the LLM via fine tuning. And a major benefit to that is really reducing the amount of system level and input prompts that you have to put into your LLM. That's going to, you know, be less of a hassle for the user. And also it's going to save people money because the amount of input context that has to go into these RAG architectures and you're paying by the token, it tends to add up after time. So reducing the cost through doing that approach is good. So you could always do a combination of fine-tuning, baking static information directly into the model itself, and you can always pair it with RAG, right? So all of these different approaches that Vijay talked about, they're not mutually exclusive, and you can kind of layer them on top of each other. Yaron, Vijay, anything to add on that?
Yeah, I can add that, you know, actually in the last session, we showed a hybrid solution with our LHF where by fine-tuning them on one end, I fully agree with Margaret, if it's data keeps on changing, you know, documents that have new updates, etc., RAG is a great solution. But what we've demonstrated in the previous conference, and I encourage in the previous webinar, was actually how we fine-tune the model to reduce the required number of tokens, make sure the model responds properly based on without creating huge prompts that force it to do things. You can also put things like guardrails. You can put things that make sure that it answers in the voice of the firm, the voice of an enterprise with, you know, what's commonly used, and you can use the fine tuning to further tune if you're talking to kids in one application, or you're talking as a bank, as a firm in a different application. You could put those things into the fine tuning, but still use dynamic content.
Yeah, and I think that sums it up beautifully. So I'll maybe take a crack at commenting on some of the questions we saw. There's multiple questions on toxicity and bias and how you guard against that. So really the one major approach that you can use is this concept of LLM as a judge. So rather than relying solely on human evaluation, you can tap into the power of these language models. And one of the things you can do is build custom trained classifiers, which can do the scoring for you and determine if something is considered toxic content or biased content. So that piece of the puzzle can be automated. That's the data collection and classification. And then the other piece of it is then monitoring and keeping track of how these toxicity and bias metrics trend over time, and be able to adapt your data pipelines and your LLM application to respond to those changes as they occur over time.
Yeah, that makes a lot of sense. I see there's a few that are open here. So one question that just came in was, while using a RAG model, kind of to add on to what you guys were talking about, how can we confirm most real data? You know, I also wrote, please, you know, explain again which RAG models are most accurate. So maybe if you can explain a little bit more about when using RAG, how do you differentiate between what's real data, what's not?
I'm slightly confused by the question, but I think maybe is it around like LLM tendencies to hallucinate? I mean, this is one of the benefits of RAG, is that it is your own data, and it is like in a database, if you will. a vector database. And essentially within the Databricks solution, we're kind of cheating when we set it up, and it makes the setup a little bit easier, which is that all of your data is already sitting within Delta tables, and we're simply adding another column that's going to house all of the values, all the vector values. The benefit of that is, not just simpler setup, but all of your Unity catalog kind of access controls at the row and at the column level are now like tied to those vector values. And so that's kind of how you can dictate like the access controls for your RAG solutions. But in order to confirm most real data for a RAG model, I mean, I would say it is your data. And the benefit of this is like, you could set up your system where when the model gives you an output, it will point directly back like a citation to where it retrieved that data and give you like a couple sources and links so you can go check and see for yourself where the data came
I think the point here, I assume, is also around verifying that it's a correct data from the RAG, from the document itself, and not from the model, service hallucination.
Mhm.
We've seen some of it, and one of the easiest way to do the evaluation is essentially take the answer, take the original data that was generated from the vector database, and do association between the two. Make sure that the content, the response, is associated with the data from the database versus the data from the model. There's I forget the acronym for that technique, but that's one of the techniques to validate in RAG solutions that the data is actually taken from the RAG and not from the model itself.
Thanks, Yaron. There's another question here that I want to take a minute to respond about any industry standard guardrails against banking and PII confidential data. There's a lot to worry about in the banking industry right now. So I guess are there the many banks, are there different banks that are open to exposing data for pre-training on your cloud? So if you maybe could take a minute and discuss the challenges in that banking sector and what guardrails you would use in order to secure the business or the banks in general. I think that would be very interesting to discuss.
So I can take some discussion here, and Margaret could follow. But anyway, obviously data privacy is a big concern in those applications. There are also other concerns like bias, for example, between different groups of, men, male, female, or between different types of communities, and so on. And so one of the ways to deal with the data privacy is apply either anonymization or filtering in all the different 4 places I mentioned. So the first place would be in the data engineering. Before you even train the model, or before we even index data into the vector database, make sure you remove all personal identifiers, emails, telephone numbers, names, and so on. Or privacy could even be in code. If you're using code, try not to upload code in the examples, code that belong to the organizations, into those places. The next place is when you're doing the evaluation of the application and the testing, verify that there are no responses that include private data. You can also do that in the application pipeline itself. As you're getting requests or responses, you could apply that in real time, those filters. And finally, you can also do that in the monitoring. If you log all the requests and answers, you can apply something sort of in batch or explore, obviously it's slightly later in the game, but it's always good to do that as well and verify there are no privacy risks. I think that another major risk would be hallucination. It's not a legal risk, but it could. We've seen it how it can. You could generate a fake answer, and that answer would open you to liability. Because if the bot is saying yes, we support this thing, or we have a current promotion which you don't have, etc. No, the bot is the company. So then the company has to confirm with that. So in my view, the hallucination is still the unsolved problem, and there are different techniques as we discussed, LLM as a judge and so on, but this is still somewhere where you need to be more cautious.
So we only have 1 more minute left. I just want to, all the questions that weren't answered we'll answer in our MLOps Live community. We'll go ahead there, and Margaret and Vijay, there were some specific questions about Databricks that you can answer offline as well. Just want to take a moment and share the results with everybody. Let me pull that up really quickly. So the first question, where are you on your GenAI journey? So you can see a lot of people are learning about their GenAI journey. Some have actually begun. They're building a GenAI app. Some have, 20% have a specific use case, and 16 have a GenAI app in production. So that's really interesting to understand and see. And also, we want to see which LLMs do you use most. So if you can see now, GPT, 79% there. Mistral, Anthropic, there's Llama, there's diverse, breakdown over here, and some have an other as well. So at this point, the Q&A is always such a fun part of the webinar. I want to, just take a minute and thank Margaret and Vijay and Yaron so much for this fantastic presentation. Thank you all for your great questions and engagement in the chat. Really, really appreciate you joining us. And I also encourage you to look at on our website. We'll share now iguazio.com/MLOps to read more MLOps resources for you. We have additional webinars and blogs and videos. And we look forward to continuing the conversation in our community. And for the next webinar, stay tuned. Thank you, everyone, for joining us.
Thank you. Bye-bye.
Bye.